Okay, so here's the picture of differentiation. Look at this. When you want to master differentiation, the first thing that you should know is first thing is differentiation of the five differentiation of the five types of functions. So listen, they split the functions for you. Some come in P1, some come in P3. Okay, listen. When you are differentiating, the first thing that you must know is, how do I differentiate? So in real life, in the situations you made in life, you can represent all the situations, engineering, medicine, all this, using functions. And there are five types of functions that you should know if you're an A-level student, okay, doing P3. We say layate. These are the five types of functions that every student must know. This L represents logarithmic functions. And the one you should know at A level is y equal to ln x. Or they can write it as f of x equal to ln x. This is the logarithmic function that you know at A level. When you go on to do university maths, calculus, you're going to do different logs. But this is the one you should know at A level. And Rovimbo, you must know how to differentiate this. You must know what do you get when you differentiate this. So that's the first part, knowing what you get when you differentiate each of these functions. Are we together? I represents inverse trig. Inverse trig. And this is proof that A-level maths is easy, because for inverse trig, they only want you to know one, which is tan inverse of x. They want you to know how to differentiate y equal to tan inverse of x. Right, so sometimes you can put it as f of x is equal to tan inverse of x. Here. Okay, this is the first stage. Keep watching. So you should know how to differentiate ln x, tan inverse of x. And the good thing is that these versions are given in MF19. So that's good. I'm going to show you where it gets complicated. They also then want you to know how to differentiate A, which is algebraic functions. These are the ones you did for P1. Algebraic functions are also called polynomials. In P1, all of you did these. You did polynomials only. You never saw ln x. You never saw tan inverse of x. You didn't see them. All you saw was this one, the polynomial. For example, y is equal to x to the 3 plus 2x squared minus 9 or whatever. They want you to know how to differentiate this one. Well, you use the power rule for this one, okay? For the polynomials, you use the power rule, where you say you drop the power to multiply and you reduce it by 1. Isn't you know? You drop the power to multiply and you reduce it by 1. That's how you were doing it for your AS, right? This is a basic type, and all of you must know how to differentiate something like this. We'll work on it. We'll work on it together, but I trust you do. Are we moving together? Can you see this, Nikita? Good. Then the other thing that they want you to know is how to differentiate trig functions. This T represents trig functions. Trig functions, now these are 6. The T represents trig functions. These ones are 6 of them. And you must know how to differentiate all of them. And you're given in the table. You should know how to differentiate sine x, y equal to sine x, right? Then cos x. Then, so here we'll put it as a table. We can say This is y or f of x. Then this is going to be dy dx or f prime of x. The 6 trig functions that you must know are sine x, cos x, tan x, sec x, cot x, and cosec x. You should know what you get when you differentiate each of these 6. You should know that when you differentiate sine x, you get cos x. When you differentiate cos x, you are going to get negative sine x. When you differentiate tan x, you get sec squared x. When you differentiate sec, so sine and cos move together. Sine gives you cos, cos gives you sine. But when you do cos, it will give you sine as a negative, so it gives you negative sine. But they still give you each other. Sine gives you cos, cos gives you sine. And it's the same here. Tan and sec, and it's the same here as well. So tan will give you sec, but tan is more powerful. So tan will give you sec squared. But sec can't give you tan squared. It will give you sec x, it comes, then it gives tan x. So it will give you this version. It first comes again, then it puts tan x. These two are related again, cot and cosec. And cot is the stronger one. We know that they give you each other. Cot is the stronger one, so it will give us cosec squared x. But cosec is weaker. It can't give you cot squared. So what will it give? Cosec x, then cot x. And you should know that these last two will be negative. They will be negative. So far, write this down. Write this down. So far, what you are seeing is what we get when we differentiate each of the 5 types of functions that we meet at A level. Sir, are these the only 5 that are there in life? No. We have what we call hyperbolic and inverse hyperbolic. You do them later. But at A level, you should know only these 5. These are the only ones that you're expected to know by your syllabus. The last and final one is this one, E, which represents exponential. So this word, liate, I want you to master it because it's coming back in integration. It's coming back. So everyone should know the 5 types of functions that you meet at A level and what you get when you differentiate each of them. So here, I gave you what you get when you differentiate the trig, but I didn't give you what you get when you differentiate log. So let me give you. For log, you should know that dy dx here will be 1 over x. I'll give you the full table. Here you should know that dy dx for this one, are you writing with me, students? Okay, should know that dy dx here will be 1 over 1 plus x squared. For here we said you just drop the power and you reduce it by 1. For the polynomial, we said you drop the power and reduce it by 1. So if it is for this one, then you're, okay, you say dy dx will be drop the power to multiply and reduce it by 1. We call it the power rule. So, what I've given you is the derivatives of the 6. We are left with 1, which is the exponential. So, the exponential function, which one is it, sir? Y is equal to e to the x. When x is a power like this. Dy dx, the derivative, will be e to the x. It doesn't even change. So, this is the beginning of your problems. Don't think you are done. You are beginning. The first thing that you should know is what I've put for you here. And you are given it as a table, which we call the common derivatives table. You are going to be given all these 5 types of functions and their derivatives. Okay, they'll skip polynomials because polynomials, you know that you drop the power, reduce it by 1. In this case, you'd write, if it's for here, you'd say dy dx would be, drop the power. So here is 3, you drop it, it comes down. Then you reduce the power. It was x to the 3, it becomes x to the 2. Plus, here you drop down the power again. Here next you drop down the power again on 2. This 2, you drop, it multiplies this 2, it becomes 4, x to the 1. Then, which is just 4x. Then the derivative of 9 becomes nothing. There's no power to drop down. So this is the power rule. Drop the power, reduce it by 1. We'll do more examples, but everybody should know polynomials. So these are the 6. Let's put it now as the table. So summary. So we call it the common derivatives table. Students, don't be boring students. If we have done the common derivatives table, don't make us come back to it. We don't have the time. So once we are done with the common derivatives table, we should move on to the next thing. You should make sure you master it. The common derivatives table basically is the derivatives you must know. So this would be y, which is the original function. Then this side will be dy dx. Or you can say this is f of x and the other side is f prime of x. Let's put the derivatives. I'm not happy with where the table is. I want to put it where I can show you all the derivatives one time. So let's just say cut, and we put it here. The common derivatives table. Common derivatives table. So our common derivatives table. Let's put all the things you must know. It's liate. Remember, we want to know the derivatives of liate. So we start with L. What does L represent? Logarithmic functions. Which one is it? ln x. That's the logarithmic function. What do we get when we differentiate it? We get 1 over x. Okay? Then what does I represent? Inverse trig. Which inverse trig should we know? Tan inverse of x. What do we get when we differentiate it? 1 over 1 plus x squared. Okay, tan inverse is an inverse trig because the trig are those 6 sine, cos, tan, sec, whatever. Those are the trig. So when you say tan inverse, it was there on the list of trig. And because it's inverse now, it is an inverse trig. All the other inverse trigs are there, but for A level, you only have to know this one. Why? Because it's the easiest one. So you have no excuses. Then you go to the third one. which is going to be, so we have done inverse trig, whatever. We can skip algebraic or the polynomials. These are just x's with powers. That is where you just drop the power, reduce it by 1. So that's easy. We go to the next one, which is t, the sixth trig. So you need to put the sixth trig. Sine x, cos x, tan x, sec x, cot x, and cosec x. So 4, 5, 6, 7, 8. Derivative of sine, remember sine and cos are related. Sine gives you cos. Cos gives you negative sine. So they give you each other. Sine gives you cos, and cos will give you negative sine. Then you keep going now. You have tan and sec squared. Tan and sec, they are related. Tan and sec, they are related. Once you get to tan, you'll be knowing that this is the stronger one. They are related, but the stronger one is tan. So it will give you sec as a squared. So it'll be sec squared x. But sec x cannot give you tan as a squared. So it will come sec x, then put tan x. I'm not even big on you cramming the table. I'm doing this so that you know it, but you can be able to use the MF19 when it comes time to use it. What I'm going to need to teach you is how to then use MF19 properly. How to then use MF19 properly. So now, cot and cosec are related. So that means when you differentiate one, it will give you the other. When you differentiate the other, it will give you one. So cot should give me cosec, cosec should give me cot. That can never be broken. But cot is the stronger one. So when it gives you cosec, it will be squared. So it will be cosec squared x. Cosec can't give you cot squared. So it will come, then it will put cot x. So this will be the derivatives. Now, you have one more type of function to know, which is the last one, which is exponential function. Exponential function should be there in our table, which is going to be, what is the exponential function? It is y is e to the x. So we gotta put it. Sorry. You gotta put y is e to the x. What do you get when you differentiate e to the x? You get e to the x. So guess what, mathematician? You now know the first part of this journey. You now know how to differentiate all the 6 types of functions, the 5 types of functions. You now know. Don't be scared. You now know. If you know this table, then you know the first part. These are, hello Velvet, Velvet Thunder 15. These are the 5 types of functions. These are the 5 types of functions. You must know how to differentiate them. Now your journey is beginning. You know the first part of differentiation. It doesn't have one part. It has 3 parts. So now we are going to the second part. I'll end here, okay, on the second part. So now you know how to differentiate each of these. So Ruvimbo, do you agree with me that you now know how to differentiate a logarithmic function, this ln x? You now know how to differentiate it, right? So logarithmic is not a problem for us, is it? No. Good. Okay. Derek, do you agree with me that you now know how to differentiate the inverse trig? There's only one inverse trig, right? Which is tan inverse. And we know how to differentiate it, right? Good. Nikita, do you agree with me that you now know how to differentiate the 6 trig functions? Do you agree with me? Good. So sine we know, cos we know, tan we know, all this we know. So the trig functions, they are not a problem for us, okay? The trig, these guys, the trig functions. We are not afraid of them. They are not a problem for us, okay? These are the trig functions. And we all know how to differentiate the exponential function. So in terms of knowing how to differentiate each of these, we are fine. But now you go to part 2. There is a new problem now. Now we have a new problem. How do you differentiate this? Y is going to be equal to e to the x sine x. You know how to differentiate e to the x when it's alone. We have it in the table. We know how to differentiate sine x when it's alone. We have it in the table. But what do we do when they are now multiplying like this? Because when they multiply, we count them as one thing. When things multiply or divide, we count them as one thing. So we have now, on the 5 types of functions, we are having them mixed up. They are multiplying each other or dividing each other. If they were adding, it would be easy. If they say, please differentiate y is e to the x plus sine x, you say, this is easy. Because you say dy dx would be, we differentiate them 1, 1. 1, 1. So don't run. You do e to the x. You look at the table, derivative of e to the x is e to the x. So here, it would be e to the x. Plus, you now differentiate sine x. You go to your table, the derivative of sine is cos. So you just come and say, okay, it is e to the x plus cos x. So this is the true dy dx. We give you 3 marks. But what about this situation, Mr. Man? Or y is ln x over x squared plus 5x. What about this situation? Now, remember, you're a mathematician. You don't live from guesswork. We never ever do guesswork. When you do something, the question I'll ask you is, what rule did you use? Don't just say, I think. You think? What rule was that? Because you're going to need to construct cars, buildings, medical equipment, all this. And you cannot guess. It won't work. So I can't allow you to guess here. You have to know, what method do I use in this situation? So this is now part 2. How do you solve when the 5 types of functions are combined? When they are multiplying, or when they are dividing, or the third situation is when one is put inside another, to say y is ln of x squared plus 5x. Look at this. So instead of ln x, we have put this inside of ln x. This is what we call a composite function. So these are the 3 situations which you now need to know how to handle. When they multiply, how do you differentiate? When they divide, how do you differentiate? When you have one inside another, how do you differentiate? Sir, is differentiation for mad people? Like, why are we doing all this? Differentiation is so useful. You cannot know when food will expire. You cannot know the speed at which something is moving at. You cannot know the rate at which anything is happening if you can't differentiate. So you want to make efficient engines, you want to make efficient whatever, you use differentiation. So that will come later. You're going to be taught how to apply this in your different fields. But now you must know how to do it. How do you differentiate when they multiply? So I want you to be able to recognize these situations. Remember, you must see when they are giving you two functions dividing each other. You should see, oh, I have a logarithmic on top. In the third situation there. You should see, I have a logarithmic on top, and I have a polynomial at the bottom. And they are dividing each other. So I must know what to do. Oh, I have an exponential here, and I have a trig here, and they are multiplying each other. Oh, I have a logarithmic here, and I have a polynomial. It's not multiplying. It's not multiplying. If it was multiplying, it would have been ln x, then open bracket, x squared plus 5x. But the ln doesn't have an x. They have put this whole thing instead of x. So you should know how to handle it. Let me give you this. So those rules, product rule, quotient rule, and chain rule, they are used when the functions are combining somehow. Either the functions are dividing each other, you use the quotient rule. Or the functions are multiplying each other, you use the product rule. Or you have one function inside of another, you use the chain rule. And the chain rule is one of the most important ones because it comes everywhere. They put chain rule inside of product rule. They put chain rule inside of quotient. So I'm going to show you. So say the second part of differentiation. Students, what you have learned so far is how to differentiate the 6 or the 5 types of functions when they are alone. Now you are seeing how to differentiate them when they're combined. So differentiation of combinations of functions. This is where the rules came from. Combinations of functions. So we do the first one. It is the product rule. So in brackets you say used when two functions from Lie8 are multiplying each other. It is used when two functions from Lie8 are multiplying each other. Okay? E.g., y equal to e to the x sine x. Okay? Exponential multiplies trig. Okay? Because this is exponential, this is trig. So, it's good for you to know when this rule is used. Now, you must know how it is used. Let's see what it says. Master the rule, because when you're doing this situation, you have to use it. You can't do your own thing. You get a big, fat 0 because you are not using rules. So you now write to say, if y is equal to uv. uv, this is first function. Okay, let's just say if y is equal to uv, where u and v are functions. Where u and v are functions from lie 8. U and v are functions. So basically, two functions multiplying. This is the product rule now. If y is equal to uv, then product rule is teaching you how to differentiate this. Then dy dx will be equal to, you bring the second function, v, you multiply by derivative of the first, u prime, plus you bring the first, then multiply by derivative of the second. So you're going to need to practice now. Second times derivative of the first plus first times derivative of the second. I'm going to show you application of this, but you must use this, okay? First times derivative of second. Like this. First times derivative of second. So this is the product rule. What we were teaching you is how you are going to do it. We'll do examples. Let me do the example. Example. Find the derivative of y is equal to e to the x sine x. This is the question. Find the derivative of y is e to the x sine x. Now you say solution. Solution. What you must see, the reason why I taught you all the 5 types of functions and we did their derivatives is when you see the situation, you must recognize it. You must recognize to say, ooh, they are multiplying. This is an exponential, this is a trig, and they are multiplying. So you use the product rule. This is the product rule. You now say, y is equal to e to the x sine x. Now you say, let u, which is the first function, u represents the first function. Isn't we had u, then v. So the first function, which is u here, is e to the x. So you say, let u be equal to e to the x. Then you say, comma, v be equal to sine x. So you've asked to let u be e to the x and v be sine x, the second function. V is the second function, which is sine x. Now, differentiate them both. Differentiate them both. U prime is, what is the derivative of e to the x? According to our table, remember, what is the derivative of e to the x according to the table? Derivative of e to the x is what? It is e to the x. So we say e to the x. Then we differentiate v, because we're going to need them. What is v prime according to the table? V prime. What is it, Mr. Derek? What is the derivative of sine x according to our table? It's cos x. So here you say cos x. Okay? You have to know derivative of e to the x, sine x, cos x. You should be good with your table. Good. So I'm happy. You differentiated them individually. Very well. Now do the product rule. So you're going to say dy dx, this is you now writing, is equal to the second times derivative of the first plus the first times derivative of the second. Plus the first times derivative of the second, like this. So it's the second times derivative of the first plus the first, which is u, times derivative of the second. So you now say, what is the v? You just take it, sine x times derivative of the first, e to the x. Derivative of e to the x is e to the x. Plus the first, e to the x, times derivative of the second, cos x. Now you can write the final solution. It is e to the x sine x plus e to the x cos x. You have used the product. And I want you to get to a point where you can do it one step. You don't have to say let whatever. Okay? I'm going to make you master it. Through questions. So product true, are we fine with the product true? Are we fine? All right. So what I'm going to do is I want to give you questions. Questions where you're going to apply product true and differentiate these ones. This is not where it ends. It actually gets to you now applying chain rule in each of these situations. So I'm going to do the quotient rule and the chain rule, and I'm going to show you the secret I saw, that chain rule is going to carry your A level. Chain rule is the biggest thing you must know. I'll show you what I mean by that. Because if you are not good at the chain rule, then you won't be able to use this table that I've just given you. Because let me tell you something, students, okay? You won't be able to use this. Let me tell you something. In the exam, they are not going to be nice to you. When they give you this one, which is in the table, the sign, they're going to make it harder. I don't want to show you right now because you can end up forgetting what I've said. But they're going to make it harder by giving you a function which needs chain rule. So I'm going to explain to you what chain rule really, really is, and how it comes in this table and in all the rules we're going to do. So we need two more rules that we're going to do: the quotient rule, then the chain rule, and we are done with this. We will now go to, we'll do a lot of questions. Then we will now do the third part of differentiation, which is application. Actually, if I can say differentiation has 4 parts, it will be still fine. Because the fourth part of differentiation is you knowing 2 other rules, which would be, how do you differentiate implicit functions and parametric functions, or parametric equations. I'll tell you that is the last. But after that, we'll do application, where you are now being asked to find rate of change. You're being asked to find equation of tangent. You're being asked to find all this. All those things, you can only find them after you differentiate. So you are going to be given a question. They'll ask for equation of tangent, or blah, blah, blah. Whatever they ask for, equation of normal, whatever. You can't think about those things. That's called application. You are using the derivative to find them. the first thing you have to do is this: differentiate that guy. Then when you have differentiated him, you will now use the derivative to find the things they want you to find. So we'll talk about it tomorrow. Hold on to this. You have to keep looking at this. Then we'll build on it, and we have to do a lot of questions. Because me explaining to you and you like a speech doesn't help. Here I've given you how it works. We are going to do a lot of questions together. So I'm going to give you 2 more rules tomorrow. Once we have those rules, it now will apply. It will now help us to be able to do questions. We'll do questions together, and I'll be polishing you guys up to make sure you make no mistake. Are we together? All right. Good. I'm happy. You are dismissed, everybody. We meet tomorrow, same